All right, so like I said before last week, we talked about how you can simplify if you happen to have an even-powered variable or an odd-powered variable. Even-powered variables means that they are perfect squares. You just divide the exponent by 2, and that gets rid of the radical. If it's an odd-powered exponent, then you just remove one of the bases. So it would be a base to the first power. And then what you're remaining with is a base to it's an even power. And then you take that even power, divide it by 2, and get rid of the radical. So it just simplifies it like that. Before, when we were talking about how to work something out if it was just numerical, let me go back to some old notes. When it's things that were just numerical, we had to find the factors. So we had to find the factors of the number, right, of the radicand. Find all the factors, and whatever was the largest perfect square factor, those were the factors that we used. So like, for example, 48, we were able to break it down into square root of 16 times the square root of 3. And then square root of 16 is a perfect square. That gives us a 4, so we'd have 4 square roots of 3. So now what we're going to be doing today is we're going to combine what we know about how to break our numbers down and what we know on how to break our variables down. We're going to combine those together. So go ahead and turn to the back of that sheet. On the back of the sheet, you should see all of these problems have numerical and variable radicands. Okay, so that's what we're going to be working on for today. So when we have a variable and numerical radicand, what we're going to be doing is separating them out as individual problems. Just like I did with the variables. If we had more than one variable, I separated them out like, okay, I just focused on the x's, and then I focused on the y's, and I focused on the z's. Well, here we're going to do the same thing. We're going to focus on the numbers, and then we're going to focus on the variables as separate problems, and then we combine their simplified radicals together as one expression at the end. So for here, we have square root of 512 m to the third power. I want to break this apart. I'm going to first focus on just the number. I'm going to focus on just the number first. All right, so let's go ahead and break this down. I'm going to go ahead and highlight 512 in blue. So I'm going to break that apart, pull it out, and do square root of 512. Okay, that's one problem that I'm going to focus on. And then I'm going to go ahead and pull the m to the third power. I'm going to use orange for that one. And separate that. So we have the square root of m to the third power. Okay, now what I'm going to do is I'm going to focus on each of those individually as if they were their own unique problem. I'm going to ignore the other. I'm just going to focus for right now on that square root of 512, and I want to break it apart. So here's where it becomes really important for you to understand those perfect squares. If you know your perfect squares, it's easier to break this apart because you can work backwards. So you want to work backwards from 512. What perfect square happens to be smaller than 512? You can even get out your perfect squares list. Here. All right, if you've got your perfect squares list out, what you can do is you can look at these. So 512 would be somewhere around here towards that bottom, right? It'd be somewhere between 529 and 484. So you just start working your way down and go, okay, well, obviously 512 is not divisible by anything in the 400s, is it? All right, it's too big. So you want to keep working until you get somewhere close to the 200s. That makes a little bit more of a reasonable concept, right? So 289. Do we think that 512 could be divided by 289? No. What about 256? Yes. 512 can be divided by 256. How many times can it be divided by 256? Twice. If you do 256 times 2, you're going to get 512. Having this list here, since you can't use your calculators, having the list available for you makes it a lot easier for you to see what you can break it down by. If you don't have a copy of the list, I'll get you one at the end of class. Okay, so what we're going to do is we're going to break this apart again. Square root of 2 is not a perfect square, but square root of 256 is a perfect square? What is the square root of 256, guys? Should have had this memorized. 16. Square root of 256 is 16. So when I take the square root, do I need to have the square root symbol there anymore? No, I don't need the radical sign anymore. That's where the biggest mistake comes from. A lot of people think that they need to keep the radical sign, and then they're like, oh, 16. I can take the square root of 16 as well, and I'm going to break it down to 4. And oh, I can take the square root of 4, I can break it down to 2. No. Once you take the square root symbol is gone. You don't do it again and again and again. Okay, once you've done it the first time, it's over. Okay? Here, we cannot simplify it any further. It stays the square root of 2. So we've just finished breaking down our numbers. Square root of 512 is broken down as 16 square root of 2. Now let's focus on the variables. Is m to the third power a perfect square? Yes or no? No, because it's an odd number, isn't it? So remember, we pulled just one of the bases out, so square root of m. And what am I going to be left with? M to what power? To the second. So I get square root of m to the second power. Square root of m to the second power is a perfect square. Remember, if I take the square root of an even number, I'm dividing it by what? 2. So what's 2 divided by 2? 1. Do I have to write the 1? No. I don't have to write the 1 as an exponent. Okay, I no longer need the radical sign there either, because I just took the square root of it. And then square root of m. That's my non-perfect square. Remember, at the very end, you want to put all of your simplified radicals, the ones that are no longer in the radical sign, you want to put them to the front. Everything that is still inside of a radical sign, you want to put it under one roof. So our final answer here is going to be 16m. You always put your number first, and then you go in alphabetical order of your variables. So these are all of my no longer inside of a radical. And then I do one square root symbol, and what's going to go inside is the 2m. That's it. That's your final answer. Again, you just split each individual term, or not term, I can't say term, but each individual base as if they are their own separate radical. Take the numbers apart, take the variables apart, and work them out as if it was just a single problem. Once you've worked it out as a single problem, you can then combine the answers together. Let's take a look at problem 6. Yeah, number 6 is easy. Okay, again, we're going to focus on the numbers first. We've got the square root of 100. And then we've got the square root of x to the 6th. Okay, square root of 100, is that perfect or not? It's perfect. It is a perfect square. Square root of 100 is a perfect square, so I'm going to go ahead and change the color to pink so that I know it's perfect. And what is the square root of 100, guys? 10. Okay, what about x to the 6th power? Is that a perfect square or not? It is, because it's even, so I'm going to go ahead and change that color to pink as well. And what is the square root of x to the 6th power going to give us? X to the 3rd. Okay, so our final answer, we're just going to piece them side by side. We get 10 x to the 3rd, and that's our final answer. That was an easy one because everything was already a perfect square. I'm going to do one more with you, and then you're going to do a couple of them on your own. Let's go on to problem number 7. So again, we're going to break these all apart. We're going to focus on the 200. We're going to focus on the a to the 9th. And this one we actually have an additional ones. So I'm going to use purple for this last part, b to the 4th. Okay? So square root of 200, square root of a to the 9th power, and then square root of b to the 4th power. Focusing on all those separately. Let's start with square root of 200. Square root of 200, again, focusing on your sheet, we're looking for any numbers that are less than 200. So we've got 196. Can 196 divide into 200? No. What about 169? 144? 121? 100? Yes. There's your perfect square then. And it's 100 times what? 2. 100 times 2. 100 being the perfect square, so square root of 100. And 2 being the non-perfect square, square root of 2. What is the square root of 100? 10. So we get 10 and then square root of 2. Okay, now let's focus on a to the 9th. A to 9th, is it perfect or not perfect? Not perfect because it's an odd number. So we remove one of the a's, so we have square root of a is off to the side. And that leaves us with square root of a to the 8th power. Good. Right? If we remove one of the a's, take one away from 9, you're left with an 8, a to the 8th. And then a to the 8th, all we have to do is divide it by 2. What do we get? A to the 4th. Do I need the radical sign anymore? No, because I just took the square root of it. Square root of a, you can't simplify it any further, so you have to keep it as square root of a. All right, b to the 4th. B to the 4th, perfect or not perfect? Perfect. So we're going to leave it. We're going to change the color to pink, so I know that it's perfect. And what is the square root of b to the 4th? B to the 2nd. Can I leave my answer like this? No, I can't. I need to piece all of the material that is no longer inside of a radical. I need to put it in the front. And all the stuff that is inside of the radical, I need to put it under one house. So what's going to come to the front is 10, a to the 4th, b to the 2nd. And then what's going to go inside of the radical is 2a. Final answer. I want you guys to go ahead and do problems 8, 9, and 10 on your own, please. All right, let's take a look at problem number 8. We have square root of 147, a to the 7th, b to the 12th. Ooh, they're loud over there. So we're going to go ahead and break this apart. We have the square root of 147. Then we're going to have the square root of a to the 7th. And then we're going to have the square root of b to the 12th. Okay, so what about square root of 147? Who can tell me what 147 can be broken down by? Armando? 49 times 3. Very good. So you can break this up into square root of 49, which is a perfect square. And then the square root of 3, which is not a perfect square. Square root of 49 is going to give us what? 7. So we have 7 square root of 3. 7 square root of 3. All right, what about the square root of a to the 7th? How can we work that one out? Square root of a to the 7th. Divya? Very good. You can split it up as square root of a to the 6th, which is perfect, and square root of a, which is not perfect. Okay? And then square root of a to the 6th is what, guys? A to the 3rd. Okay, so we have a to the 3rd, and then square root of a. What about b to the 12th power? Square root of b to the 12th. Yochan? B to the 6th, because it already is perfect square. b to the 12th is a perfect square, so you can simplify it to b to the 6th power. Okay? Last thing I have to do is rewrite all of this so that everything that is no longer in a radicand, everything that's considered a coefficient is in the front, everything that's a radicand is inside of one radical. So we're going to put 7, a to the 3rd, b to the 6th, and then square root 3a. That's our final answer. Okay, let's take a look at problem number 9. We have 250x, square root of 250x. So we're going to do the square root of 250 separately, and then the square root of x separately. Amy, how did you break 250 up? All right, do it right now. How would you break 250 up? I'll pause until you're ready. So 250, we can break it up into 25 and 10. 25 and 10. So we have square root of 25, and we have the square root of 10. Maya, what's the square root of 25 going to give us? 5. So we're going to have 5 square root of 10. Okay, what about square root of x? Can we simplify that? No, it's not a perfect square. And can we pull any perfect squares out of x? Yes or no? Why not? Because it's already an exponent of a 1, right? If it's already an exponent of a 1, that's as simplified as it's going to get. So it's going to stay a non-perfect square. So square root of x. Okay, now we piece it all together, and we're just going to have 5 square root of 10x. That's our final answer. Okay. Next one, 128. 128, Soo-Jung. How would you split up 128? 2 times 64. Good. Okay, so square root of 128 is going to be split up into 2 and 64. 64 being your perfect square, square root of 64. And 2 being the non-perfect square, square root of 2. Okay, square root of 64 is going to give us what, guys? 8. So we have 8 square root of 2. All right, x to the 10th. X to the 10th. Kenneth, how are we going to deal with x to the 10th? Very good, because it's already a perfect square, isn't it? Already a perfect square, so we're just going to take that exponent and divide it by 2, and what do we get, Kenneth? X to the 5th. Good. Okay. Y to the 7th. We've got y to the 7th. Davinia, how are we going to split that up? Okay, so tell me what I'm going to write. Okay, so y to the 6th, square root of y to the 6th, and square root of y. Okay, what's square root of y to the 6th? Y to the 3rd power, and then we have square root of y. Okay, so we piece it all together. We get 8 x to the 5th, y to the 3rd, and then square root of 2y. You want to make sure that you have everything simplified as far as it can, and you piece it all together. Okay? You guys have on Google Classroom, you've got 2 IXLs, but hold on, wait, I forgot. One thing I forgot to mention, and I usually mention it later on, but the IXL uses it now, so I'm going to give you an example of what to do if you've got a number outside of your radical as well as numbers inside your radical. So let's say that we've got something like 5 square root of 45. what to do with a problem like that. 5 square root of 45. That means that we're going to break the 45 up, square root of 45. We're going to split that up like normal. Square root of 45, we can break it down into square root of 9 and square root of 5. But then you've got this 5 that's in the front. So this 5 is going to get multiplied to whatever coefficient we come up with that's going to be in the front. Okay, so this technically means we're going to be doing 5 times 3 and then square root of 5. What's 5 times 3?
15.
15. So this becomes 15 square root of 5. Okay, so when you have 5 square root of 45, you break the 45 apart separately, and then you're just taking whatever the coefficient is on the outside and multiplying it by the new coefficient that you've created. Okay, I'll do one more example, and I'll leave these up here for you. Let's say that we've got a problem like 2 square root of 32. We have 2 square root of 32. So the 2 is just going to stay separate. 32 is what we're going to break apart. 32 can be broken apart as square root of 16 and square root of 2. What's the square root of 16? 4. 4. So you're going to take that 2 and you're going to multiply it by the 4. 2 times 4 is going to give you 8. And then the square root of 2 just stays on the square root. Okay, so these would be how you would work those problems out. Please be mindful of those kind of situations when you have a coefficient already outside of the radicand, or sorry, already outside of the radical. It's not considered a radicand, it's considered a coefficient. All coefficients need to be multiplied together to be in simplest form. Okay, get on to Google Classroom, work on the 2 IXLs.